In this video, we're going to be diving into classes. This video is going to get you familiar with classes for behaviors versus classes for blueprints, and it's going to set you up for some challenges later on in this section. So up through this series until now, you're probably familiar with classes through MonoBehaviour. And remember, MonoBehaviour allows us to attach scripts to game objects. So for example, in our last challenge in the coroutine sections, we created this whole class that made this rainbow effect. And it's inheriting through MonoBehaviour, which allows us to attach this to a game object, right? Same thing as this spin and spawn kind of script. It inherits MonoBehaviour, and it has these behaviors, spawning and spinning, which this script is sort of acting as the behavior for this cube, and because it inherits from MonoBehaviour, we can attach the script to that game object. Now, to show you an example of what I mean for a MonoBehaviour script, in this window guy game, we have a bunch of different classes. Let's take a look at the player class. And don't worry, as you're looking at this, if you don't understand everything that the code is doing, what's important for you to understand in this section right here is how the code is organized. Right now, if we take a look at update, everything right here is within our update loop. And as I add more and more functionality to this game, it gets harder and harder to debug. If something is wrong with the way my player moves, or the way they animate, or the way they jump, I have to dig through all this code in the update. One thing that we can do within classes that are made for behaviors is we can create custom methods to store individual features of our behavior. For example, I can create a void calculate movement, and in here, I can put all the code that has to do with movement, paste it into here, and I can just call calculate movement in the update loop. And I can make another method for what this code is doing, which is calculating our animation. So void calculate animation, and in here I can take the code that relates to animation, paste it into my custom method, and then call that method from update. Now our player class is much easier to read and understand what's happening, right? I can look at update and I can tell we're calculating movement, we're calculating animation, and if there's ever a problem later on with either of those features, I know exactly where within my code to look. This right here is the core functionality of object-oriented programming. It's the ability to organize your classes to create easy to maintain scripts. Now, it's time for us to look at an example of a script that doesn't inherit MonoBehaviour, right? Because everything up till now has been behavior for objects. We have a script for the player, a script for the coin, a script for the car, a script for where the camera is, but there's a totally other way to use your scripts, and that is as a blueprint. So I'm going to do a little demo, and you can follow along with this if you want to, but this is meant to be a presentation for you to get ready for the challenges that are coming in the next video. However, if it's helpful, totally follow along. Okay, so let's say, for example, I'm creating a game that has a player script. So I'll create a MonoBehaviour script, and I'm going to call this my player, right? This is a regular script that I can attach to a game object, right? I can put it on this cube. And let's say that the game that I'm making has a magical RPG spell system that I want to add. In C#, we can actually create classes within classes, right? Like this script right here is for the player, but I can go all the way up here and I can create another class. I can say public class, and I'm going to call it spell stats, and then just open up curly brackets. No MonoBehaviour needed. You can think of custom classes like this, since they don't inherit as MonoBehaviour, you can think of them as a blueprint. So we want to ask ourselves, what are the traits that we want our spell stat to have? Perhaps we want a name, we want a type of spell like fire, ice, poison, whatever, and maybe lastly we want like damage, like how much damage it does. And in a real video game scenario, obviously your custom classes would probably have way more than this, but let's start simple. So let's say I have a public string name, I have a public, we'll just do string for now, spell type, and then maybe an integer, public int damage amount. Now that we've made this custom class, how do we actually use it, you might be asking? Well, we need to create a variable that will store what kind of spell our player is using, right? So in our player part of the script, we can create a private spell stats, and now I can call it what kind of spell. Let's say our player has a fire spell, right? I could just give it a name. And this right here is creating an object that holds holds this information that we defined up here. So this fire spell has a name, it has a type, and it has a damage amount that we can set. So for example, I could go in the start method and I could say fire spell equals a new spell stats. Now that we've created an instance of that object, we've instantiated it, and now we can populate the data of this fire spell. So I can say like firespell.name equals flamethrower. The firespell.spell type equals fire, and firespell.damage equals 100. And now that I've set this information up, we can actually pull this data through the UI system and display that information to the user, right? We could say what spell we have equipped. And now what if I wanted more than one spell, right? We can do the same thing. We can create another private spell stats. I could call it my ice spell. And in start, we can say ice spell equals a new spell stats. Ice spell.name equals iceberg. Ice spell.spell type equals ice. And lastly, ice spell.damage amount equals 75. But take a second and imagine if we had 50 different spells, 100 different spells. Does it make sense for me to instantiate these one by one like this? Absolutely not. Super tedious. Don't want to do this job. One thing that you can do with a custom class that is acting as a blueprint is you can create a thing that is called a constructor. A constructor allows you to initialize things. So instead of typing out these lines right here, the name, the spell type, the damage amount, we can use a constructor. The way that we do this is we go into our custom class above, and we are going to create a public spell stats, right? Parentheses and brackets, just like a method. This right here is called a constructor. And what we can do here is we can pass parameters in through these parentheses to our constructor. So we can say we take in a string name, a string type, and a string damage. And from here, what we can do inside these curly brackets is we can say this dot name equals name, this dot spell type equals type, and this dot damage amount equals damage. Oh, it says it cannot convert string to int. That's because this is not a string, it's an integer, so it's matching what this is. Cool. This way, when we initialize our spell, we can automatically pass through and assign these values. So in the start method, instead of typing everything out like this, and this is underlined in red because now we have a constructor that's taking in these parameters for us. So instead of having these 3 lines, what we can do instead is we can type them in right here. Flamethrower, it's a fire, and look at our tooltip. These are the parameters that we just wrote in: string name, string type, and int damage. So flamethrower, fire, and the damage is 100. And now we can do the same thing for our ice spell. Say iceberg, it's an ice type, and the damage is 75. So we can now initialize new spells with just 1 line of code. And the way that this is working is it's taking in the data, flamethrower, fire, 100. It's passing it up through this constructor. It goes through the constructor, and then it gets initialized right here. And now, just to sort of show how this is working, let's throw in a debug.log, and we will say like spell plus, let's say firespell.name. I'm gonna go ahead and save the script. So we just have the player script attached to a cube. Look at what it says. In our console, it's printed out spell flamethrower. So this is an example of how to make use of constructors in custom classes that can define properties for us. Just to sort of illustrate this point a little bit further, I'm gonna create really quickly a UI, let's say a text object, and this is gonna be, oh man, if you're following along this window right here, go ahead and import it, the essentials and the examples and editors as well, just so we have something to work. So super quick, this text right here is just gonna be our spell text, and so we can see it nicer, I'm gonna align it to the top left, scale with screen size, there we go. Okay, I'm gonna really quickly create one more script that is a MonoBehaviour script, and this is going to be a UI manager. Attach the UI manager script to your canvas and go ahead and open it up real quick. Once again, this is just for an example. If you're following along, awesome. We're going to make a public method, public void update spell stats, and it will take in a spell stats, and we'll call it spell. So we're gonna call this from our player. Maybe we hit number 1 to select our fire spell. We hit number 2 to to select our ice spell, and it will display on the screen what spell we have selected. So in our UI manager, all we want to do is we want to get a reference to that text object. So TM Pro, we're going to say public text mesh row GUI, and we're going to call it spell text. And we will say spell text.text equals name plus spell.name plus type plus spell type. Oh, spell.spell type plus damage spell.damage. Right. So all this is doing is it's going to take in a spell and it's going to print out the information of what we have selected. To make this wicked easy, let's just turn this into a singleton real quick. That's a private static UI manager called underscore instance. We'll get into the singleton pattern later on in the series. We'll make a public static manager, capital I instance. Again, don't worry too much about what this is. This is making it really easy for us to access the UI manager from other classes. Say it has a get method, which if the instance is null, throw an error real quick, and then right underneath this if we'll return the underscore instance. And lastly, one more down in void awake, we will set instance equal to this. Okay, so if you're following along, here's the whole code for the UI manager, and then back in our player, super quick, let's just code some input. Let's say if input dot get key down key code dot alpha 1, and let's say for this UI manager dot update dot instance dot update spell stats, and we're going to pass in our fire spell. Now let's say if we press 2, if input dot get key down key code dot alpha 2, then we will go UI manager dot instance dot update spell stats, and we'll pass in our ice. Sweet. Save your scripts and hop back into Unity, and on your canvas it's looking for a spell text, so I'm just going to drag that into there. And if we hit play, all right, well, as soon as I hit the number 1, it now says name flamethrower, type fire, damage 100. If I hit 2, name iceberg, type ice, damage 75. So this is just an example of how to make use of constructors in custom classes that can define properties for us. It's awesome. As the last part for this, before we get set up for our challenge, you might be asking, when and why do I use a custom class versus just making a separate script for everything? So imagine the same game where I have all these spells. Imagine that I also have a bunch of different weapons. So let's say I'm going to right click and I'm going to create MonoBehaviour script for a bow and arrow, right? And all the stuff that has to do with my bow and arrow is in there. Let's say I also decided that I'm going to have a shield. So I'm going to make a MonoBehaviour script and I'm going to call this one shield. Okay, so now I have a bow and arrow, I have a shield. Let's right click and let's create another MonoBehaviour script. And let's say that I also want to add a hammer, right? Each of these scripts, the bow and arrow, the hammer, the shield, which I spelled wrong, would define what that weapon, what that item does. Does it make sense for them to each be their own script? No, absolutely not. Especially imagine if I had way more than 3 weapons, right? If I had 50 or 1,000 weapons or weapons that you combine into other weapons, it makes way more sense to make a custom class, right? So the bottom line of how do you know when to use a custom class versus using a class as a behavior for an individual object is you need to look for patterns and look at where groups of things share commonalities, right? Each of those things I just created, the bow and arrow, the hammer, and the shield, all have similar traits. They all have a name. They probably all have an ID. They probably have a description. They probably have an attack strength, and probably even more things than that in common. So it makes way more sense to create one custom class where we could define each weapon since they share similar traits, right? Same things with items, things like materials, like crafting items, spells. When groups of things share common traits, it might make sense to create a custom class. All right, and with that, you are all the way set up. You have all the information that you should need to attempt our first challenge. All right, I will see you in the next video where you will have your first challenge creating a custom class. See you then.